Hello guys, welcome back to the channel. Today we'll be solving LeetCode 15 3 sum. This question is a variation of the very popular question 2 sum. If you have not already solved the question 2 sum, I would like to suggest you guys to look at the problem and the solution. I have already posted the video on that question. Um, and if you guys have already solved the problem, then I think you guys can solve this question because it is somehow similar to the quite similar to that question with an like extra step. So let's begin this question without any further delay. So this is the question. Given an integer array nums, return all the triplets num I, num j, num k such that I is not equals to j, I is not equals to k, and j is not equals to k, and nums I plus nums j plus nums k equals to 0. It basically means that do not, if you're taking nums I equals to this first number, don't take either j or k as the same number. It basically says that. So in the two sum problem, we had the target and we had to find I and j such that like nums plus nums j equals to target. So this was the question, but here what we have to do is what we have to do here is plus nums k equals to 0. So what we can do is take every number as a target, just like in two sum, and find other numbers from here, find I and j such that this condition is met. But what we have is we have the repetition of number. We have -1 here and -1 here, but we do not want repetition of we don't want duplicate triplets. So what we can do for this is sort the array, but sorting will not solve the entire problem. What we can do is if we sort the array, we will have all the duplicate value in a same place. It means that these are the duplicate values. So if we find nums I and nums I -1, we can just continue. We don't have to like take the same number as a previous number and go on. We can just continue so that we skip the value. So how can we solve the problem? So we can solve the problem by taking I as each number of array after sorting, obviously, and then j can be I plus 1. So in this question, if I is this one, so this is the j, we can do j, and this we can put is k. So what we can do is since this is unsorted array, we can add this thing. If it is equal to 0, we can add into result. If not, what we can do is calculate the sum. If the sum is greater than 0, if the sum is greater than 0, then we know the positive value, the positives in the sum is greater than the negative. So what we can do is shift the rightmost pointer so that we decrease the sum. So we can keep k here, and once again go along, and if the sum is less than 0, we can shift the left pointer, and we will shift this left pointer and right pointer until j is less than k, because we do not want to repeat since if we reach in an equilibrium position, we have already checked on the left side and we have already checked on the right side, so we don't want to do the process again and bring repetition, which can create more duplicates in our result. So we can do this. Now let's begin the coding session. We will also see some edge cases that can occur in the solution. We don't have the massive edge cases in the example, so we'll see in our coding session what edge case can occur, and we'll also solve the problem. So let's go to the coding. We are at the coding session. So before writing anything, let's write the algorithm that we created. We have to sort the array first, then we have to loop into an array and take every element as num1 to check triplet. Take left pointer at I plus 1. Take right pointer at lem nums minus 1. This is the end at the last position. Take the sum. If the sum is greater than 0, shift the right pointer. If the sum is less than 0, shift the left pointer. If equal, append and look for another solution. Okay, now let's sort the nums. So here we were able to sort the nums for I in a range len nums minus 2. The reason we have nums minus 2 is because we're using, for every number we are using 2 pointers. The first pointer is at I plus 1 and the last pointer is at the end of the array, so we don't have to go to the end because 2 spaces is already taken by the 2 pointers. So we can do that, and j equals to I plus 1, k equals to len nums minus 1. So we will do calculate the sum. Let's keep this here. Sum equals to num1 plus nums j plus nums k. If sum is greater than 0, shift the right pointer, that is k minus equals to 1. If sum is less than 0, j plus equals to 1, else we append create a result. We will append into the result, append the array which is num1 comma nums j comma nums k. So since there is a possibility of having two different solutions, like an example here we have -1 as an I with -1 and 2 as one solution, and -1 with 0 comma 1 is another solution. We can have other triplets as well. So we will shift j to further and k in the backward direction. So So this basically gives you the result, but we have some cases where there can be duplicate results. So, and we have already been told that we don't want the duplicate results. Just like in let's see another one. What can be the example? So minus 2 comma 0 comma 0 comma 2 comma 2. So let's see at this result. So we have an I8 here. We have I8 here and J8 here and K8 here. So for the first solution we will get minus 2 comma 0 comma 2, and after that the pointer will shift, J pointer will shift to this position and K pointer will shift to this position, which basically gives the same result. So what we can do is create a condition that if j equals to norms at j equals to norms j minus 1, we just continue it. So if we do that, when the j is this, it will basically gives minus 2 comma 0 comma 2 as a result. But when we reach here, it will check a condition, and it will just add it will add more, like it will add j will be added, which will reach here. So we can do that. So let's do, so while nums j equals to nums j minus 1 and j is less than k, but we do not want to like make changes, and we still want to be in this condition. So we add j. We can also one condition that that if there is a repetition of I as well, then we don't want to check again, because the first number, what I basically means is if I is here and next time the I goes here, we don't want to check because we have already checked 0 is the first number, so we don't want any duplication. So we can also add one condition: if I is greater than 0. We have to do that because there can be, we don't want to like check I minus 1 when it is the first index. And nums then just continue. So let's try running this. Sorry, this is not an optimal. So I always get confused with the methods and functions. So the test case is accepted, so let's submit it. So it beats 91.64% of users with Python 3. So this is a very optimal solution. What we could have done is create a set. If we had like created a set, we didn't have to do these edge cases, because instead of array, the set does not want a duplicate value, so it would basically be easier, I guess. But using that way, the runtime will increase. We have created a memory, we need extra memory to create the set. So basically using the array will be faster, and since we're still in array in this blind 75, so I chose array to solve the problem. So thank you guys very much for watching this video. If you like this video, just give a thumbs up, comment if you have any other ideas or any problem with the solution. And also that I'm still in the learning phase. I'm creating this video so that I have better understanding of different data structures and LeetCode problems. So if you have any doubt with the solution with anything, just feel free to comment down, and don't forget to subscribe. Thank you very much.